So, amino acids are our monomers. They are linked together by forming peptide bonds, and we talked about those chemical reactions yesterday. The dehydration synthesis or the condensation reactions, those link amino acids together, but the bonds that are formed are peptide bonds. Once we have a peptide bond, we now call those polypeptides. Poly meaning many, and peptide is a bond that is formed between the amino acids. So I could call a polypeptide that's composed of 2 amino acids a dipeptide. If it's composed of 3, a tripeptide. But then after that, we just call everything polypeptides. So most polypeptides are very large, like thousands and thousands of amino acids together, because proteins are very big molecules. But what we do need to know is that every polypeptide has a linear sequence of amino acids, like amino acid 1, 2, 3, 4, 5, and they all line up in a row. And we're always going to have one end of that polypeptide that has the carboxyl end on it, and we call that the C-terminus because there's a carbon in a carboxyl group. And the other end of that polypeptide is going to be the N-terminus because that's where the amino group is going to be. So there's going to be a C end and an N on the other side. C-terminus and N-terminus you do need to be familiar with. So let's look at this model. We see that we already have a peptide bond that is formed between the 2 amino acids on the left, and we see a dehydration synthesis reaction occurring on the right, and I know that that is a synthesis reaction because I see the loss of water. Remember, water is always lost when bonds are formed with those dehydration synthesis reactions. But looking at this polypeptide, what I want you to notice is look at the amino acid that has the yellow R group. That one has the amino group on the N. So I would say that that is the amino or the N-terminus. And then all the way on the right, when we're adding that new amino acid to the growing polypeptide chain, that one's going to end with the opposite. That one ends with the C-terminus because the carboxyl group's on the end. And then one final thing that I want you to take a look at is where we see that new peptide bond forming between amino acid 2 and amino acid 3. Notice that a carboxyl group always joins to an amino group. So amino groups can't form condensation reactions because then you're just going to have 2 hydrogens come together. We always have to have an OH and another H to lose that water. So our carboxyl group is always added to an amino group, and that will always happen for polypeptides. Here we see that synthesis reaction has occurred, and now we have 2 peptide bonds in this growing polypeptide chain. I could call this a polypeptide, or I could call it a tripeptide because it's made of 3 amino acids. Another thing that I want you to look at is the backbone. And on this model, it's on the bottom. It's always going to have all of the hydrogens at the bottom. It's always amino to carboxyl, amino to carboxyl, amino to carboxyl. We don't see the R groups interspersed. They're all on one side of the molecule, and that is something that you need to know as well, is that the side chains or the R groups are always, when in primary structure, they're always like going in the same direction. So we have 3 amino acids up here, and they're in different colors because they have different R groups. And you might have to look at these R groups and determine which ones have similar properties, because the properties of the R group are really important in determining the overall structure of the entire protein. So what I see is that the R group in green has that OH at the end. I see a lot of hydrocarbons, but I see an OH at the end, or that alcohol group. That tells me that that is a polar amino acid, and that's going to love water, so that's hydrophilic. In the middle, see in yellow, that R group. All of those are hydrocarbons, and hydrocarbons are hydrophobic. So one thing that you have to memorize in AP Bio is that hydrocarbons are hydrophobic. And then finally, the last amino acid in blue, that one's easy. I see a plus, I see a charge. That's a basic R group. That has a charge, so it's going to be hydrophilic. So if I had to look at the 2 amino acids that had the most similar properties, I'm going to choose the 2 that I know that are hydrophilic. So the amino acid in green and the amino acid in blue, those are both hydrophilic. Those have similar properties because the one in the middle is made of hydrocarbons and it's hydrophobic.